Okay, let's go over this together. So we have this chemical. How do we find the molar mass? How do we do that? Yes, I'm combining some of your answers. You add the periodic table, you add how many of each there are, right? So in this compound, diethyl sulfoxide, how many hydrogens do we have? Okay, do we see that? So hydrogen times 10, there's 10 of those. Plus, what else do we have? We have carbons. How many carbons? 4. Okay, carbon times 4, good. And what else do we have? We have how many oxygens? 1 oxygen and also 1 sulfur. Okay, so be ready for something that's tricky like this. Okay, you have to multiply each of the carbons by 2. So we've got 2 here, 2 here. You have to multiply this by 2 and this by 2. Okay. Do we see how we got all those? Okay, then we add it up. And this is one on the final that will tell you how many decimals. There's not very many of them that do that. But this one, you don't have to figure out sig figs. It will specifically tell you what to round to. Okay. What did you guys get for that? Did you do that?
106.1752.
106.752. What is it?
1752.
1752. Okay, and then we're rounding to 1 decimal place, so this would be 106.2 grams per mole. Okay, and that's that unit there. Okay, you think you could do that on the final? Okay, all right, great. Okay. All right, let's jump into chapter 8. Chapter 8 has some math. So I don't remember if we went over this in this class. Chapter 8 has some math, chapter 9 has some math, and then chapter 10 only has 5 topics, but they're pretty straightforward. So as long as you're ready for those 5 topics, you'll be good. Chapter 11, 12, 13 are all organic chemistry, and they're just like being familiar with the material. So basically, if you memorize the content in chapter 11, 12, 13, then you're good. And usually people do very well on that. So there's no math in those ones. Okay. So kind of think about, we're getting closer to the end. We have 8, 9, 10, 11, 12. We have 6 chapters left. Okay. So kind of think about, now is a really good time to, if your grade isn't where you want to, make sure that you're getting your assignments all the way completed. And also do the tests, get as good as you can on the tests, because again, your tests are worth a lot of your grade. And we do have 2 more chapters that have some math that sometimes tricks people up. But the last couple chapters, people tend to do really well. So do your best in these last 6 chapters. Okay, there's hope. We're almost there. Okay, let me pull up. I have my Alex open. I might have walked by now. Oh, yes, I signed out. Okay, let me sign back into my Alex. While I'm signing into Alex, does anyone have any general questions for me? Or specific questions? Okay. All right. So I have a list of topics that we're going to go through. Let's see if we can get through the first 3, and then we'll see where we are, and then maybe we'll do our lab. Maybe the first. That was the first thing. Chapter 8. We're in chapter 8 now. Okay, the first topic we're going to do is identifying the correct sketch of a compound and an aqueous solution. So we talked about aqueous before. What does that mean, aqueous? So maybe your neighbor remembers. Check with your neighbor. See if your neighbor remembers what aqueous means. All right, what did you guys decide? What does aqueous mean? What do you remember? Okay, and the liquid, in aqueous liquid has to be specifically water. So something dissolved in water means aqueous. Okay, so we're talking about solutions in chapter 8. So we're going to look at what happens to a substance when it dissolves in water. So if it's an ionic compound, do you remember what happens if it's ionic? When we did lab 4, we had to show this. Do you remember? Someone remembers? Okay, so let me write it down somewhere. Camera? There we go. Something track. So if it is an ionic compound, it will split into its ions if it's aqueous. I don't need this. So aqueous means dissolved in water. Okay. And then we're going to see what happens to different compounds. So if it's ionic and it's aqueous, okay, then it's going to split into ions. Okay. So for example, sodium and chlorine. What's going to happen? What ions make sodium and chlorine? So sodium's in the first column. So I know that sodium's going to be a +1 charge, Na+. Chlorine is in the 7th period. So it's going to be Cl-. It makes a -1 charge. Okay. So these things come back and come back. So they just got to know those. Okay. If it is, I just handed you a sheet. These are acids and bases that you have to know for chapter 9. But these are also examples of, so specifically the acids. Sometimes the bases will also come up. But if it's an acid or a base, they will also split into their components. Split into ions in solution. So let's look at an example. These are the strong acids and strong bases, and it gives this is the weak acid that Alex requires you to know. This is the weak base that Alex requires you to know. But anything that has hydrogens that can come off is an acid. So let's see. Let's just look at one. So if I have HCl, you have to be able to identify that as an acid. So I'm looking for a hydrogen in the front. And the more that you see these, the more you'll pick up on them. So practice this topic so that you're comfortable with those. If it's like H3C, that's a covalent compound, not an acid. So you have to kind of be able to pick up on if it's a lone hydrogen at the beginning, can that hydrogen break off? Is it an acid? This one's not an acid, this is a covalent compound. Okay, so we kind of have to distinguish those. So hopefully we'll see some examples like that in our topic here. So here, HCl will break into its pieces. It will be HCH and then Cl minus, H plus and Cl minus. Okay. And it's a little bit confusing because we haven't talked about acids and bases, but we will talk about them in chapter 9. But we do need to know a little bit about them for this topic. Okay. All right. The other one is a base. So a base is just a compound that splits up into its ions, just like, these are all ionic. Okay. So it's a base, but it's also ionic. So if you can recognize this as ionic, you'll know that it splits into its pieces. So let's look at sodium hydroxide. Let's do potassium because we haven't used potassium. So this one's a base. Potassium hydroxide. I know it's a base because it has OH. Okay, if you notice on your list, all of those have OH. They're all bases, these ones. Okay. So this one is going to split into K plus, that's a metal. So metal, non-metal, that's how I know it's ionic. And then OH is OH minus. Okay. And that's in solution. Okay, we need to know that because the first topic we're going to talk about is what happens when we put a substance in solution. Where's Alex? Oh, all right, missed that one. Okay. All right, so this one, we have sodium nitrate. Is that ionic, covalent? Is it an acid? So what do you think? Is this ionic or covalent? All right, do you remember remember that? Let's maybe write a definition. So if it's ionic, then almost always it has a metal and a non-metal. Does that sound familiar? Hopefully. If it's covalent, then it has only nonmetals. There's a tricky exception. So if I have ammonium and anything, so remember ammonium is NH4 plus. If I have ammonium with something else, like ammonium nitrate, NO3, or ammonium chloride. If I have NH4, that's ionic because I have an ion. So NH4, NO3 minus. Okay, NH4 plus, Cl minus. Okay, so these ones are ionic even though there's no metals. That would be our exception. If we see ammonium, then that's going to be ionic. Okay. You guys are quiet. I'm having a hard time knowing if you're following. Okay, so we have sodium nitrate. So I have a metal and a nonmetal. I have a metal and a polyatomic ion. So when this splits into its pieces, so Na, NO3, well, we've already looked at sodium. Sodium forms a plus charge. Nitrate forms a minus charge. Okay, so I'm looking for an atom, and then I'm looking for nitrate, so something that looks like this. Okay, this is kind of like a molecule. This whole molecule has a negative charge. And then if it's in solution, we should also be looking for water. So somewhere in our solution we need water. Okay, and probably lots of water is floating around. Okay, does that make sense? That's what we're looking for. So we're looking for a model that represents this well. And they give us some options. So this one is not true because we have something and then we have this other thing. We need two, we have two different atoms. The other thing about this is how many sodiums to how many nitrates? This is 1 to 1, right? They both have Sodium has a plus charge, nitrate has a minus charge. I need 1 to 1. So this is one type of ion to 3 types of ions. This other ion, so if this is my sodium, this other ion, maybe this is the anion, there's 3 of them, and there's only 1 element in that. Nitrate has 4 atoms and it has 3 oxygens and a nitrogen. So we need something that represents the polyatomic ion. Okay, so that's wrong. Next one. This is the whole thing together, but I know this is ionic because there's a metal and then a polyatomic ion. So this needs to break apart in solution. Okay, and we got our water floating around in the back. Okay, this one is looking good. I have my nitrate represented with, so nitrogen and 3 oxygens, that's represented well. And then I have a sodium. And for every sodium, I have a nitrate. For every sodium, I have a nitrate. It has to be charge balanced, okay? So this one's looking good for us. Let's keep looking and see. Okay, this is just 2 things together. Yeah, we have sodium and nitrate, but this is not a good model, okay? In an ionic compound, it needs to split apart. This one's not split apart, so that's wrong. Okay, this one just like, oh, look, we have 3 different types of atoms, and they all break apart. No, that's not true. Sodium breaks apart from nitrate, but the nitrate doesn't break apart in solution. Nitrate is a covalent ion. The nitrogen and the oxygen are bound together by a covalent bond. Okay, this is just, I think they're trying to represent sodium and maybe the nitrate as 1 piece, but this isn't 1 atom, it's 4 atoms. So that's wrong. This is also wrong. The ratio of elements is wrong. This is also wrong. Okay, so does that make sense? You kind of piece together what you're looking for, a model of, and then find that. Okay, next one. CO, is this ionic? No, this is not ionic. If it's not ionic, it won't split into ions. Okay, it also doesn't have any hydrogens. It's not an acid and it's not ionic. So we're looking for a molecule. So CO dissolved in water will stay as CO. So we're looking for something that represents carbon bonded to oxygen floating around in water. So, oh, that's not true. They're all split apart. Also, we need 1 carbon for 1 oxygen. So that's not representing that well either. Okay, we have way too many atoms there. This one is not right. There's too many types of atoms. Okay, this one looks pretty good because I have 2 types of atoms. I have a carbon and an oxygen represented, and I have the carbon bonded to the oxygen. Does that make sense? In solution, the carbon does not break apart from the oxygen because it's covalent. That's wrong. This one's showing they're breaking apart. That's not true for covalent compounds. This has 3 types of atoms. This has 3 types of atoms. So this is going to be our best option. Does that make sense? Okay, let's do a few more. The hardest ones are the ones with the acids. So let's see if we can find an acid. Or this one's a base, I guess. All right, let's go through this one for fun, and then we'll do this one, and then we'll look for an acid. Okay, so this one, what is this molecule called? Yeah, good, ammonia. Good, so this is one that you have to remember for the test. Okay, ammonia, is this ionic? This one's not ionic. So this one has NH3, so that's just covalent. This one's just covalent. This has hydrogens, but if it's an acid, the hydrogens will show up as at the very front, and it'll be like 1 hydrogen by itself. So this one's not an acid, it's not ionic. So we're looking for something that shows nitrogen connected to 3 hydrogens, and that's going to be the best model. Let's go here. Well, that's nitrogen connected to 2 hydrogens, so that's not quite what we're looking for. Not quite what we're looking for. That's showing that everything is breaking apart. That's not true in this compound, in a covalent compound. This is not true. There's too many types of atoms. They're all breaking apart. That's not true. This is the ratio is incorrect here, and they're breaking apart. This is almost there because we have something that looks like ammonia, but we don't have anything else, so that's weird. There's like something else floating in there. That's wrong. Okay, great. This is just ammonia. So we have nitrogen and 3 hydrogens. Does that make sense? So this models what ammonia is doing in solution. We have nitrogen attached to 3 hydrogens floating around in the water. Okay, I'm still not sure if this is making sense. Okay, how about this one? Barium chloride.
Ionic.
This one's ionic. Good. So the ions are going to split. We have 1 barium for every 2 chlorines. So that means our model has to show that. We have to have, for every 1 barium, we need 2 chlorines floating around. Okay? Chlorines are not attached here to each other. They're separate. So let's see if we can find something that looks like this. Okay, this is showing them all together. That would be covalent. That's wrong. This is ionic. This is just showing, this is the wrong ratio, and they're not split. This is ionic. It's going to break apart. Okay, this is looking pretty good. We have barium and 2 chlorines. Okay, what if this one's the barium and these are the 2 chlorines? This is the barium and these are the 2 chlorines. That's looking good. Okay, I think 3 is our best option so far. Okay, this has the wrong ratio. Also, it has an extra element. We only have 2 elements that we need to represent. This is the wrong ratio. This is the wrong ratio. This is 1 to 1. We have 1 to 2. This is wrong because lots of things. We don't have 3 chlorines attached to the barium. It's ionic. We also have an extra element. So that's wrong, and that's wrong. Okay, so let's go back to number 3. This is right because all of them are splitting apart. It's ionic, and why else? Oh, right ratio. Okay, all right. Let's see if we can find an acid now. Oops, I need to just click on this. Let's see. Okay, really quick. This one sometimes gets people. What would this one be? We got the chlorines like we've been seeing, but is it ionic? No. Good. This one's not ionic. This one is covalent because we just have nonmetals. Only nonmetals, no metals. So this one's going to look kind of like water. Chlorine has 1 spot that it can bond. Hydrogen has 1 spot that it can bond. So we would look for a covalent compound, oxygen bonded to chlorine. So I'm going to go through this one pretty quick. Let's see if I can find it. So this is what this one would look like. We'd have oxygen, 2 chlorines, compound. Okay. All right, let's just keep going. I'm looking for one. Has anyone seen one that came up as an acid yet? H? Maybe this is not the right topic that it comes up on. Okay, let's look at this one. I'm wondering if it's a different topic that I'm thinking about. Or on the test that might come up. Just make sure that you're familiar. If it's an acid, it will split apart, like we've been seeing. Maybe that comes up in chapter 9. Okay, what about this one? Covalent or ionic?
Covalent.
Good, this one's covalent. This is a molecular. I guess Alex uses molecular. Okay, so this one's not going to break apart. So we're going to look for carbon with 3 hydrogens and a chlorine attached. They're not going to break apart in solution. So this one will look like this. We got carbon, 3 hydrogens and a chlorine. Not breaking apart in solution. Okay, let's look at one more. See if we can find it. Well, okay. Looks like the acid might not come up on this question. Great, that'll be better. Okay, next question. We're going to look at precipitation. And this is kind of like the lab, predicting precipitation. So you guys are a little bit familiar with this already. So let me hand this out. This is on cardstock because I want you to keep track of this. You can use this on the test if you do not write on it. Okay, this is not like an extra note card. This is like, the Alex table is really painful to use. So you can use this on the test. If you don't bring this on the test, then you will use the Alex table because it's the same thing. I just printed off the Alex table. Okay. Don't write on this or you can't use it on the test. Okay, let me show you really quick, in case you don't have your solubility chart. This is in Alex somewhere, so let me find it. Looking through the data. Solubility of ionic compounds in water. Okay, so this is just like kind of painful to use. It's like closes every time, you have to find it every time. Anyway, so you can use this on your homework. If you use it on the test, just don't write on it. Okay. All right. So, and it's there. If you don't want to pull out this card, then you can find it. So what we're doing is we're taking this compound and this compound. So think back to, you've done this. Think back to the lab. Was it lab 4? You took 2 clear liquids. It was like part 2 in lab 4. You mix 2 things together, and sometimes cloudy precipitate formed. Some solid formed. Okay. So we're mixing these 2 together. Oh, sorry, did I not? I'm sorry. Thank you for grabbing those. I apologize. So we're mixing these 2 together, and then we're trying to see if something will precipitate. Okay. So nickel and sulfate. So what they give you should be soluble. Okay. So what we're going to check is we're going to take the metal and check it against the anion. Okay, and then we'll check iron too, and check it against sulfate. Okay, with our table. So maybe I'm thinking about how to do this. Let me write it down, and that will help me. Yes. So let's see. So we're looking at nickel 2, sulfate. Okay, so a liquid, and you add it to iron 2, iodide. Okay. So what we're going to do is we're going to check, is nickel 2 iodide soluble? Is iron 2 sulfate soluble or insoluble? Okay. So is there going to be a precipitate, and what is it, and what's its formula? So let's check nickel 2 and iodide. So what I'll do is I'll go to nickel 2, that's what this one is, and then iodide. Oh, okay. Yes means soluble. That's soluble. So that means it's not going to be a precipitate. So not precipitate. So we're looking for something that's red. Okay. So iron 2, and we're looking for sulfate. Also soluble. Great. So when they're both soluble, then let's go back to Alex, wherever Alex is. And you say, does a precipitate form? Nope. This is a little bit confusing because our chart is saying yes. And if our chart says yes, that means they're soluble, and we're not going to get a precipitate. So it's like inverse. So practice that. Does that make sense? It's like a little bit confusing. So no precipitates because yes, they're both soluble. All right. Let's do the next one. Ammonium bromide and sodium chloride. I'm going to write these down. And then copper 2, chloride, and sodium sulfide. Okay, I'll just have those written down. Okay, so the first one, ammonium bromide. So this is an example where it's an ionic compound, even though we have only nonmetals. Okay, but ammonium is an ion, so it's an ionic compound. So ammonium is NH4 plus, bromide is Br minus, sodium is Na, chlorine is Cl minus. Okay, and then what we're doing is we're given this, so it's aqueous. This one's also aqueous. So we're going to see if there's a solid that forms. So we're going to check sodium bromide like the metal is going to change with the non-metal, and the other, this is not a metal, the cation will switch with the anion. So we're going to check these against each other and these against each other. So let's check ammonium first. Ammonium and chloride. Oh yes, that's soluble. Okay, so not a precipitate. Ammonium chloride. And then sodium bromide. Oh, there. So it's both soluble. Great. That makes it easy. So yes, they're soluble. Does it precipitate form? No. So if both of those are yes, then we put no on the form. Okay, next one is copper 2 and sodium sulfide. So again, this in solution is soluble. This solution is soluble. This compound is soluble. We're going to check, does copper 2 make a solid with sulfide? Or does sodium and chloride make a compound, a solid, precipitate? All right, so let's do copper 2. Let's see, copper is Cu. Copper 2 and what? Sulfide. Copper 2 and sulfide. No. So that's our first no. So sulfide. So copper 2 plus and sulfide. Okay, so this one's going to form a precipitate. So we have to write the correct formula, okay? And it helps us. It tells us the charge, so that's pretty nice. Sulfur is 2 minus. Copper is 2 plus from the name. So what should our formula be? So this one's a 2 plus, this one's a 2 minus. We just need 1 copper and 1 sulfur. Or we can show our work. We can say, oh, we need 2 of these for 2 of these. Oh, well, then we have to simplify, okay? If it's ionic, we always have to simplify the formula. So 1 to 1. This is a 1 to 1 ratio. Okay, the other thing is we can write the charges to show our work. We never write the charges in the formula. So when you put your formula in the bin to turn it in, do not put charges here. That's not part of the formula. It helps us find the formula, but we can't, it's not like the formal answer, okay? So yes, we found there was a precipitate in that form. The precipitate was copper sulfide. You should only get 1 precipitate on these. All right, so check. Okay. All right, how do you feel about this one? Do you want to do another one? Okay, let's do another one. More practice. Okay, silver nitrate and sodium bromide. Maybe if I put it side by side, then I won't have to write it out. Yeah, let's do that. Okay. All right, so the first one is silver nitrate and sodium bromide. So silver nitrate is soluble, sodium bromide is soluble because they gave them to me, okay? So then I'm going to switch the metal and the non-metal. So let's do that first. Silver bromide. So I'm going to check. Silver bromide. And we're going to check sodium nitrate. Okay, nitrates are, if you look on here, nitrates are always soluble. So that's, if you're like, I need a shortcut, well, none of these can be soluble. Or, yeah, none of them are precipitates. And then, let's see, we're looking for silver bromide. What's the atomic symbol for silver? Do we know? Yeah, good, thanks. Ag. So that's at the bottom here. Oh, silver forms lots of precipitates. So silver is silver plus, and it is silver bromide is not soluble. Okay, so this is going to be our precipitate here. And what should our formula be? Well, we have 1 silver, a silver plus, and a bromine minus, so we just need 1 of each. AgBr. No formulas no charges in the formula. Yes, something precipitated. It's called silver bromide. Okay, next one, we're going to look at iron 2 and hydroxide. So I'm just switching iron. I'm just switching the metal and the non-metal with the second metal and non-metal. So iron hydroxide. Oh, this one's so iron 2+ and hydroxide is a precipitate. It's not soluble. It's gonna crash out. So OH is minus. Iron is 2+. So this we need 2 hydroxides for 1 iron. So my formula will be FeOH2. I need parentheses to show that I need 2 hydroxides and not 2 hydrogens. All right, yes, something precipitated. This will be FeOH subscript 2. Okay, question so far? All right. Last one, nickel acetate and iron chloride. So we're going to switch. We're going to look at nickel 2 and chloride. And we're going to look at iron 2 and acetate. Okay, so let's see. So nickel chloride. Okay, that one's soluble, so that won't form a precipitate. And iron 2 acetate. Okay, that one's also soluble, so this one will be nothing will precipitate. We won't see like something cloudy or something fall to the bottom. Okay. All right, let's go to the next topic. Applying like dissolves like. All right. Okay, so this one we're trying to pick something that will dissolve it. So we're trying to find something that is similar. So if it's covalent, it will dissolve in something that is similar to it. This also takes into account intermolecular forces. So if it has hydrogen bonding, it's going to dissolve in something that has hydrogen bonding. Okay. What else? If it's ionic, it will dissolve in something that is polar. Okay. So let's write down some rules maybe. So this is just like dissolves like. Like. So polar, if it's polar, it's going to dissolve in something that's polar. So polar compound will dissolve in a polar solvent. Do you know what a solvent is? Okay, a solvent is just the substance that's dissolving. The substance that is dissolving something else. So something they call water. Water is a universal solvent. Okay. So usually it's a liquid. Another solvent is like acetone, okay, or like hexane. So like dissolves like, that helps chemists decide, okay, if I pick this, it's going to dissolve in this. Okay. All right. So if it's ionic has charges, right? It has plus and minus ions. Okay. That's going to dissolve in something that's polar because the polar molecule has parts of the molecule that are positive and parts that are negative, and these ions can interact with the polar parts of the molecule. Okay. If it's a nonpolar, it's going to interact better with something that's nonpolar. So this is like water separating from oil. Water is not a good solvent for oil because they are different. Water is polar, oil is nonpolar. They don't like to mix. Okay, like dissolves like. I think those are the rules. Yeah. Okay, let's see if with these rules we can look at these topics now. Okay, so this one, we have to decide, is this covalent or ionic? So calcium chloride. So we have calcium as a metal, chlorine is a nonmetal. Metal, nonmetal, that's ionic. Okay, so if it's ionic, it's going to dissolve better in something that's polar. So if we're looking at these two, this one's carbon tetrachloride, this one is methanol. So when I look at these, this should start being nonpolar in your mind. Okay, CCl4 is a tetrahedral molecule that's symmetrical, it's nonpolar. Okay, so hopefully you're starting to pick up on that. As soon as I change one of the elements, that's going to be polar. But if it's all four the same on a tetrahedral, that's nonpolar. So this one is ionic. We're looking for something polar to dissolve it. Because this has charges, we need a polar molecule to interact with those charges. Well, we have this molecule, methanol. This is going to be like this. We have carbon, 3 hydrogens, and an OH group. Okay. OH groups are going to be kind of key for this topic. If you can see an OH group, that's probably going to be polar. It will be polar. If it has OH groups, that also has hydrogen bonding. Okay, I guess we should also add if it has hydrogen bonding, that's the best solvent is going to be something that has hydrogen bonding. If we could choose, that's going to be something that we're going to look for. Okay, this one, we have this interesting molecule. This is going to be polar because we have this oxygen on the one side. This molecule is going to be a little bit polar, but these are most similar. So I'm going to say this is going to dissolve this better because they're similar. Like dissolves like, okay? This is covalent. These are both covalent. They're both polar. This looks most like this. Okay. All right, potassium chloride. When I look at this, I see a metal and a nonmetal. This is going to be ionic, so I'm looking for something that's polar. We just talked about this is nonpolar, water is polar, this is going to be the best solvent. Okay, let's do another one. Oh, this is very big. I think we're okay. Okay, this is one of the exceptions to the ionic rule. So you guys need to start recognizing NH4 at the beginning, okay? I see NH4, NO3, this is a ionic compound, okay? There's no metals. This is like the trick one. If I have NH4 at the beginning, this is an ion, okay? NH4 plus and NO3 minus, okay? So you have to recognize that as ionic, okay? So be careful on that one. That one's like, this is like one of the trick ones in this chapter. Okay, so if we have an ionic compound, we're looking for something that's polar. Water is a great polar solvent, so I'm going to pick this one. Water is probably the best polar solvent. This is trying to trick you because, oh, this has a nitrogen. This also has a nitrogen. Well, that's great, but this is not. This is ionic. Okay, we're looking for something polar. This would be a little bit polar. The nitrogen is going to pull more electrons, but water is much more polar, so water is going to be a better solvent. Okay, I think if you have something that's ionic, it's going to always be the best. It's going to dissolve in water. Okay, water is just a really great solvent for ionic compounds. Okay, this one is interesting. So when you see something like this, I always look for these OH groups. Okay, if it has OH groups, it's going to have hydrogen bonding. So if we can find a solvent that has hydrogen bonding, we're going to pick that. Okay, so this one has OH groups. I'm going to pick this as my solvent because it also has OH groups. So then they're going to be able to hydrogen bond, and that's going to help the compound dissolve. Okay, they're going to interact better. If I didn't have something that has hydrogen bonding, this would be pretty close solvent. But this one's better because it has the OH groups, like dissolve like. Okay, oh, this one has a whole bunch of OH groups. Okay, this is benzene. This molecule right here is called benzene. This is a nonpolar solvent. Have you guys heard of benzene in the news? This is something that causes cancer. They try to not put it in products. Okay, because it has OH groups, I'm going to pick water as the solvent. Okay, that's going to be the best solvent. This is nonpolar. This one's going to, because it has these oxygen groups, part of the molecule is going to be polar. We're going to have positive and negative pockets of this molecule. Okay, let's do one more of these and then we'll work on the lab, finish up the lab. Okay, this is drawn very weird. So this one, again, I'm looking at this molecule. I can see all of these OH groups. That's going to have hydrogen bonding. So I'm going to pick something that has hydrogen bonding. Oh, this also has OH groups. This one's tetrahydrofuran. That's kind of a fun. This is a pretty common organic chemistry solvent. All right, this one. Oh, look, we have all these OH groups. So I'm going to look for something that has OH groups because like dissolves like. Okay, methanol also has OH groups. This is similar, but this is a better choice because of the OH. Okay. All right, next one. Interesting. So we have this carbon molecule. This one has a polar bond right here. This carbon oxygen is going to be pretty polar. So this is going to be polar. Also, we have this nitrogen attached to the hydrogens. And if we drew this out, I'm just going to draw this part right here. So nitrogen connected to two hydrogens. This doesn't have enough valence electrons. This is like an abbreviated structure. So this actually has a lone pair on the nitrogen. So we have hydrogen attached to the nitrogen, and we have a lone pair on the nitrogen. So this would have hydrogen bonding. So if I can find a molecule that has hydrogen bonding, I'm going to pick that for my solvent. Oops. So this is called, let's see, how many carbons do we have? 1, 2, this is pentane. This is just a long carbon chain. This is nonpolar. This would be a great nonpolar solvent. This is polar, also has hydrogen bonding, so I'm going to pick this molecule. Okay, so this one is just kind of like a reasoning question, and you kind of have to, this one I would practice a lot to get familiar with all the different types of molecules. You can start seeing patterns like the OH groups and the, make sure you watch for ammonium, and you can recognize all the inorganic compounds, the ionic compounds. Okay, I think that was, we got through 3, right? Great. Okay, so some of us need to finish lab 6, is that right? You need to measure, no, 5. Is it 5 or 6? 6. You need to measure your nails, right? Your copper in your nails. So your samples, you washed your samples, right? You're in the other class. You were in the other class. Okay. So this class, you guys washed your samples and you were drying them, right? Okay, so they're next to the oven. Your samples are next to the oven. Go ahead and grab your lab sheet, put some safety glasses on, find your samples next to the oven. They are not hot because they've been out of the oven. They should be dry.